So in previous video I discussed what is summing amplifier, and now this video I will discuss what is inverting summing amplifier. So at first just draw the configuration of inverting summing amplifier. So this is a configuration. Because of inverting, we apply input to the inverting terminal, means negative terminal. And we apply 3 inputs in inverting terminal. So this is R1, this is R2, this is R3, this is V1, this is V2, this is V3, and this is ground, means V is equal to 0, and this is our V out and its negative feedback which we apply to the output to input. This is RF, feedback resistance. So in this configuration we will say that this is I1, this is I2, this is I3. So through this input resistance, we assume I1 is going through this path, I2 is going through this path, I3 is going through this path, and about this all, here is a current. So I will say that this current name is or represented by IF. Okay, and because this 2 terminal is virtually grounded, that's why V is equal to 0. That means in here V is equal to 0, in here V is equal to 0. So because of virtual ground, this 2 terminal is no current will flow between these 2 terminal, but voltage is equals to both of these 2 terminals. So that's why V is equal to 0, V is equal to 0, and here V is equal to 0. So for this configuration we use multiple input to the inverting terminal. So we will say that output voltages V1, V2, V3. Sorry, input voltages. So input currents I1, I2 and I3, and input resistance R1, R2 and R3. So now IF is going through this resistance RF, and assume this op-amp is an ideal op-amp and no current will flow between these 2 terminals. So applying KCL, so we will say that I1 plus I2 plus I3 is equal to IF. So I1 is equal to, if we concentrate with this path, then I1 is equal to V1 minus V0, because 0, V1 minus 0, minus sign because of voltage drop by R1. So V1 minus 0, because 0 voltage is here, by R1. So I1 is equal to V1 minus 0 by R1. Similarly V2 minus 0 by R2. Similarly V3 minus 0 by R3 is equal to, similar way V0 is here, so 0 minus V out because of voltage drop by RF. 0 minus V out by RF. So just eliminate all zeros from here. V1 by R1 plus V2 by R2 plus V3 by R3 is equal to minus V out by RF. So if we find what is VF, just find the value of VF, then minus RF V1 R1 plus V2 R2 plus V3 R3. So this is our V out. But this is so complicated equation. If we want to simplify this equation, then we do something for this equation. So just this V out is for multiple inputs. This V out. For single input is equal to V out is equal to minus RF by R in into V in. We all know that previous videos I was discussed all. So let assume R1 is equal to R2 is equal to R3 is equal to R. So now then V out is equal to minus RF by R, because if all R1, R2, R3 is equal to R, then alls are R, and if R we get common with this R, and then after V1 plus V2 plus V3. So now this is here another V out, but this is also complicated. So if I say let assume again, let assume RF is equal to R. So now V out is equal to minus V1 plus V2 plus V3. Because if RF is equal to R, then RR, just eliminate both R's, and then V out is equal to minus V1 plus V2 plus V3. So in this way we can use the op-amp as an adder, so we can add the multiple inputs. So adder, and we can add some multiple inputs. Now this is a one application for inverting summing amplifier. Now I will say that some inverting summing amplifier is also used for a scaling operation. Then how? Let's discuss it. If I say RF by R1 is not is equal to RF by R2 is not is equal to RF by R3, in that case V out is equal to minus A V1 plus B V2 plus C V3. How it's come A B C? So A B C represent the ratio of A is equal to RF R1, B is equal to RF R2, and C is equal to RF R3. So along this addition we can also perform scaling operation by inverting summing amplifier. Thank you.